Assalamualaikum warahmatullahi wabarakatuh. My name is AHMAD ZAKWAN bin ZULKIFLI. Okay, today our group will present about our lab 1, which is design and analysis for the disc brake. Okay, so my part is for theory and there's some idea of safety factor calculation. Okay, so for the theory, as we know, this brake consists of rotor instead of drum and use a pair of flat lining pads forced against rotor for the braking process. Okay, next, structure consists of caliper which hold one or more piston with seal and dashboard. It's also using hydraulic pressure for pushing the piston during braking process. Okay, so as a result of the braking process, the vehicle will slow down and stop the wheel. Incident as a piston stuck in the caliper may happen if one pad worn more severely than the opposite side. Okay, as we know, for the maintenance, brake disc also need to renew for all each tire. We cannot renew for one tire only. Okay, so braking process may produce harmful items such as asbestos. Okay, so as safety precaution, do not clean the brake disc using air compressor. But we need to wear mask and glove. Okay, so for the safety factor, as we can see the diagram, it shows that the formula for the safety factor. So the main purpose of the importance for safety factor calculation is related to the people safety. Okay, it also can reduce the risk of a failure for some component that exists in the system. There will be some hidden circumstances that cannot be considered accurate in design. Means that the load used in design is not also the maximum load. So this ensures the protection against those unknown events to some extent. So use the system by following design. Limit even have been provided with safety factor. So it can enhance more for people safety. So that's all for me. Thank you.
Assalamualaikum, my name is UWAIS SB bin LOTFAN SB. My metric number is B0920102990, and I'll be explaining the procedure of this lab session, which is lab 1. First, we must draw the disc brake rotor by referring to the narration in the lab sheet. After we have done draw the brake disc rotor, we will proceed with analysis. So to start the analysis, from the brake rotor disc part, we will select the start on the left top, and then go to analysis and simulation and select generative structural analysis and start the static analysis. After that, we will proceed to clamp the brake rotor at the center hole, and we will use the surface slider on the surface of the brake disc rotor and the front and the back, the rear face. After we done surface slider, we will select the distributed force, and we will select the part which is the brake piston, brake pad, that will simulate a brake pad force. After we done select the brake pad area, for the force we will put about 2680 Newton, and for the front we will use the negative to make the force going the opposite side. After we done this process, we will select the rotation force and select the body, and the rotation axis will be the center hole edges. After we done select the edges and make sure the turn is 900 turn per minute, and then we will compute the process, the analysis. Then we will go to insert and select the frequency case, and untick the restraint MSS and tick the static case solution. And for the reference, we will select the static case solution 1 from the previous static case. and then we will compute. After the process have done compute, you can see the von Mises and for every analysis on the brake rotors simulation. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Alright, I'm gonna explain about the data finding and structure for the structure analysis of the design. So, defining the material properties of the disc brake rotor, we use a material name gray cast iron G1800. So, as stated, the Young modulus of the iron is 9.7 exponent 10, Poisson ratio 0.26, with a density of 7150, and has a thermal expansion 1.1 exponent negative 0.5, and yield strength of 177 exponent 0.8. So the result on this analysis, we got the max displacement, the max translational displacement vector with a frequency of 732.61 Hz with a maximum displacement of 389 mm. So as we look at further, we have a von Mises stress analysis, so we can see that the maximum von Mises stress we can obtain from this analysis is 1.73 exponent 0.11. So between the yield strength that our material, we choose the material provided, it shows that the max von Mises stress has a higher value than the yield stress. So the factor of safety may not be efficient as we would obtain. So calculating the factor of safety for this analysis, we get a factor of safety of 0.00102, which is smaller than 1 and not considered as a safety brake disc rotor to use. So it was considered under design. So as I deep into the Google source, I found that the factor of safety of a disc rotor has to be 1.5 minimum. The differences is high in value, so in order to counter that part, we must improvise in terms of design or material use. So that's all for me. Thank you.
Assalamualaikum. For factor of safety is very important because it increase the safety of people and reduce the risk of failure of a product. It essentially used to assure the structural design does not occur any unexpected failure or preserve of deformation or defect. The smaller the factor of safety, the higher the chance that the product will fail. The design and material for this brake rotor play an important role for its factor of safety. The maximum von Mises strength for this brake rotor is 0.173 tera Newton per meter square, and the minimum von Mises stress is 0.747 mega Newton per meter square. To find the factor of safety for this brake rotor, first we must know the yield strength for gray cast iron G1800, which is 0.177 giganewton per meter square. Then it's divided with the maximum von Mises stress. The factor of safety for this brake rotor is 0.00102, which is under design due to the minimum requirement for factor of safety of brake rotor, which is more than 1.5. In order to increase the factor of safety for this brake rotor, we can adjust its design, thickness, radius, and material. That's all from me.
Warahmatullahi wabarakatuh. My name is Muhammad ASYRAF, and I will conclude our lab. So in this lab, we are able to design the disc brake rotor according to the dimension given in the CATIA, and we are also able to define the material properties for the disc brake rotor. The design and the material is the most important detail need to be focused because it can change the structure integrity of the brake disc rotor. With all the correct material properties set, we can run the analysis. We are as accurate as in real life how the disc brake rotor structure experience. From the analysis also, we can calculate the factor of safety. Our disc brake rotor factor of safety is 0.00102, which is below than the standard factor of safety, which is 1.5. This indicates that our disc brake rotor is not safe to be used and it needs to be redesigned or changed to the other material for better performance.